Hello guys, in this video I want to find the first and the second derivative and answer when is my function is going to be concave up. So to find the first derivative, remember that the first derivative is going to be a ratio of y prime over x prime, where y prime in this case is going to be 2t and x prime is going to be 3t squared minus 12. So that's why we have the first derivative, which is 2t over 3t squared minus 12. Finding second derivative is a little bit tricky, but let me show you how to do that. So first, let's write our second derivative. And what is the second derivative? It's derivative of your derivative. And if you're going to remember how we derived the original derivative of parametric function, then you need to take your derivative corresponding to t and then over dx over dt. So basically you divide top and the bottom by dt. Then we can see what we're going to obtain. We obtain basically I want to take, since my dy over dt in terms of t, then I want to take my derivative prime over x prime. But I know what is my x prime. X prime is just 3t squared minus 12. And to find the derivative prime, I need to do a quotient rule. And according to the quotient rule, I'm going to have 3t squared minus 12 squared on the bottom, and 2 times 3t squared minus 12 minus 2t times 60. And then what do I need to do? I need to simplify my expressions. So first I'm going to move bottom part to the bottom, and I will get 3t squared minus 12 cubed. And then I'm going to do some algebra. So I'm going to get 60 squared minus 24 minus 12t squared. And so what I'm going to get negative 60 squared minus 24 over 3t squared minus 12 cubed. So you can see that my second derivative then is going to be equal to negative 60 squared minus 24 over 3t squared minus 12 cubed. Okay, our next goal is to answer about concavity. So for that, what do I need to do? First, I need to remind ourselves what does it mean like when my function is concave up or concave down. So let's recover the definition. A function we're going to say is going to be concave up if the second derivative of my function is going to be positive. But what does it mean? Let me give you an example of the function which is going to be concave up and whose second derivative is going to be positive. So let's take y is equal to x squared. Then you can see that y2 prime is equal to 2. But y is equal to x squared is going to be the parabola that looks something like this. And so that form means actually concave up. So kind of your function looks like a ball. And you can see that y2 prime is equal to 2, which is obviously positive. So our next goal is to figure out when is our function is going to be concave up, or in other words, when is our second derivative is positive. So let's rewrite what is our second derivative. Is negative 60 squared minus 24 over 3t squared minus 12 to the third power. So when that expression is positive. To answer that, what do we need to do? We need to take top part and bottom part and find its zeros. You can see for the top part, you will obtain that t squared is equal to negative 4, and there are obviously no solution. But for the bottom part, you will have 3t squared minus 12 cubed is equal to 0. So that means that 3t squared minus 12 itself is equal to 0. Or in other words, that t squared is equal to 4. So t is equal to plus minus 2. And then as soon as you have zeros of top and the bottom, and since there's no zeros on the top, so I have only zeros on the bottom, which is negative 2 and 2, then we're going to get our real line is separated into 3 regions. I choosing 0 to figure out the sign of my region in the middle, and you can see that I will have 24 over 12 cubed, so the sign is positive. By choosing 3 negative 3, you will figure out the signs of my function on those intervals are going to be negative. And what are those signs? Those signs are the sign of my second derivative. So my second derivative is going to be positive on the interval from negative 2 to 2. Again, the idea of the method is to take your fraction, to find zeros on top and the bottom. Those zeros are going to divide your real line into regions, and then you need to figure out the sign of your function on each region. To figure out the sign, you just choose any number which is not on the boundary from that region, plug in that number inside your function, and see what is the sign going to be, positive or negative. And then you're going to assign that sign to your region. Okay, so we found that our function is going to be concave up on interval from negative 2 to 2. Thank you for watching, guys. If you're not subscribed to my channel, please subscribe and have a nice day. Bye.